out tonight?
I have a functional JavaScript joke. Can I tell? Excuse me.
Sure. Tell you functional JavaScript joke.
All right. Why do you think people think that functional JavaScript is too spicy? Because there's a lot of curry in it.
Ah, okay. Well,
I like it.
we'll get to that in a second. All right. So I want to go ahead and announce a couple of upcoming events. There's going to be a JaxTech meetup on August 11th down at the Neptune Beach, and there's details and stuff online about that. If anybody's interested in going to that, it's going to be like a little social event. It's on a Friday, and a couple of other user groups here are participating as well. So please feel free to come out to that. And then we have Code Impact coming out on August 26th. And I'm actually doing the one and only Node.js presentation they're having there. It's going to be Node.js for .NET developers. So please feel free to come out to that. I also want to promote next week on Thursday over at Black Knight. We're going to be doing a presentation on kind of like modern mobile development, as far as like what are all the different options available to developers for building mobile applications. So if anybody wants to come out to that, please feel free to come out. We still have plenty of space.
It's the JaxArc SIG.
It's the JaxArc SIG. So thank you very much, Jody. So I want to go ahead and thank our sponsors tonight. Availity has always been kind enough to host the meetings here, so thanks to Availity. I also want to thank Interactive Resources for bringing the food tonight. Thanks again to Interactive Resources. And I also want to thank my company, Swift Technology. I brought these koozies here, these beer holders and stuff like that. So if you want one of those, please feel free to take one. So something else I also wanted to do is I wanted to put the word out that we're always looking for speakers. I currently do not have anybody lined up for the rest of the year for JaxNode, and it doesn't have to be JavaScript specific. If you want to do something on Electron or Golang, I'm also looking for speakers to do on Kubernetes, Swarm, or Mesos. So if you have interest in that or like to present on that, we definitely like that. Other client-side frameworks, we actually have 2 different React user groups here in Jacksonville now, but I know there's people also using Angular and Ember and some other front-end frameworks, so we'd be happy to have presentations on that as well. One I'm also looking forward to is WebAssembly is kind of a thing now, and so now we have the capability to build essentially in any language and then compile down into WebAssembly code that'll run in the browser. So I think that would be an interesting presentation there. I haven't seen a lot of stuff online yet about WebAssembly, but that's going to be pretty big, I think, in the future. If you want to do it on the NAPI, NAPI is the API that was introduced with this last version of Node for building on essentially C++ add-ons. So somebody was interested in doing that. We certainly like to hear a topic on that. And then any other JavaScript topics. So, if you're interested in doing a presentation for JaxNode, please contact me or come see me after the presentation tonight. So the focus tonight is going to be on functional JavaScript. And so I'm going to start off talking a little about some JavaScript history. We're also going to talk about pure functions, do a little talking about closures, classes versus object literals. There's going to be a fair amount of this presentation that's going to be on essentially object creation. We're also going to be talking about currying. Thank you, Jody. And we're also going to discuss higher order functions, functors, monads, promises, async and await, mutability. And we're also going to talk a little bit about the bind and pipe operator proposal. These aren't actually in the language yet. They may actually never make it into the language. But I promised Michael Sneed that I would talk about this tonight. So this is Douglas Crockford. He said JavaScript is the only programming language that people try to program in before actually learning the language. And I think there's a lot of truth to this because a lot of the developers that I've worked with, maybe have a background in Java or C# or one of those other languages, and they they look at JavaScript and it looks very similar to like Java and JavaScript, or sorry, Java and .NET in a lot of ways, but it's actually quite a bit different. And so Douglas Crockford is one of the people that's really been, I think, kind of like pushing this idea that there's he wrote a book called JavaScript: The Good Parts, talking about what are some of the good the good functional qualities of the language. So I wanted to make sure I got that quote in there. And so Brendan Eich is the guy who actually was hired by Netscape to create JavaScript. And initially he wanted to do Shim. He actually worked on some compilers and interpreters while I worked at Silicon Graphics. And he was hired there with the idea that he'd be able to do kind of like Scheme in the browser. And they told him, well, it has to look like Java. And so that kind of put the kibosh on a lot of it. But a lot of the ideas that he had as far as using a functional-like language and stuff made it into the language. And they've actually kind of expanded on a lot of the stuff that was in the original version 1.0. And that's essentially how we got JavaScript. So functional programming is essentially it's a programming paradigm. It's one way of thinking of it. Another way of thinking of it is declarative over imperative. So one of the tenets here is that you want to avoid changing state, and you also want to avoid having mutability in your code. And another thing that you see quite common in functional programming is that you'll see a lot of times where people are actually creating structures and structures of elements, and then they're using functions to do computational change over those structures. And something else that the functional programmers try to do is they try to use pure functions wherever they can, and that's to avoid side effects. So we'll get into that here in a second. So why learn about functional programming? Well, because it's awesome. So there's a lot of JavaScript frameworks already out there that really kind of rely on these functional programming concepts. So React and Redux are examples of those. So it's very common. You'll see like map used quite a bit in React, and that's an example of where they're taking advantage of some of the functional characteristics of JavaScript. Also, it helps you write code with less errors, which is a good thing. It generally results in less code, which is also a good thing. And one of the things I want to do is I want to show some of the different functional programming languages. And so I read a blog post that's probably about a year and a half ago, and it did a comparison of all the different functional programming languages. And in the blog post, they mentioned most of these languages, but they also mentioned just JavaScript. And it said, well, here's the deal. It's like JavaScript is probably the worst of all the functional programming languages, but it's the one that everybody's going to wind up using. So that's why we're going to talk about in this blog post. So I want to go ahead and kind of bring that up. Lisp is probably like the granddaddy of functional programming languages. I think it might have been created in the 1950s. I'm not really sure on that. And more recently, in the last 20 years, 25 years, was Haskell and Erlang. Even more recently, we've had F#, which is, I think, is closely aligned to like the .NET side of things, and that's probably going to expand now that .NET Core is out. Scala, of course, is considered a functional programming language as well. Elixir, I kind of like what I've seen of Elixir so far. Elixir is a lot like, I think it's like a functional language that was made for Ruby developers. This is why I like to think of it. In fact, a lot of the people I know that are doing Elixir are Ruby programmers. So, and then Bill messaged me earlier this week and said, "Are you going to talk about Elm?" And the answer to that question is yes. We are going to talk about Elm. Now we're done talking about Elm. No, I'm just kidding. So there's essentially
you could boil this presentation down to use Elm.
You stayed
We
from
could do
use
that.
Scala to use Elm?
We're gonna edit that out. So Elm and PureScript, I encourage everybody to take a look at Elm. So Elm is actually it's its own full-blown functional programming language. It has types in it, and you can actually use it to compile down and do all your coding for your web programming just using Elm. And so I've even seen mix-ups or mashups and stuff like where people are using Elm with React. So I'm not going to talk, that's pretty much all I was going to say about it tonight, but if you're interested in that, I encourage anybody to go out and take a look at those as well. So is JavaScript functional? Well, functions are first-class citizens in JavaScript. You also have the capability of using closures to use inner functions to access the parent scope. Functions can be passed in as parameters into other functions. And you can also return functions from functions. And that way it's very functional and stuff like that. There's also things that are bad from a functional programming standpoint. So the global scope, that's something that everybody always complains about with JavaScript. And I also say it's like just most types, and a lot of people like purists that use like F# as an example. It's like you can't create a mutable variable. You can only literally create the variable once. So it's like just in its nature, it's immutable. And so that's something that's also considered a quality of functional programming languages. So pure functions, what is a pure function? Well, a pure function essentially is something that you're guaranteed, no matter what the inputs are, you're always going to get the same output. And one of the things that's really nice about this is that if you're trying to, let's say, write a unit test, you don't have to worry about getting some kind of weird result and stuff like that. And so Redux is a perfect example where they try to use pure functions wherever possible for managing state. So non-pure functions. So non-pure functions essentially are functions that have side effects. So in this example right here, you can see that there's a state variable outside the scope of the function, and then every time this function, this add to state function calls, it's going to get a different result. So if you look at C1 and C3, you see that they both passed in the same inputs, but they got different outputs. So that's an example of where side effects have come into place, and this is not a pure function. This is an example of a closure. So if you look at this very carefully, one of the things you'll see here is that we have this private counter variable in here, and then we have an inner function, this change by function. And one of the things that this function will do once it's created is that it will return a new, essentially an object literal that has these different methods in it that you can call. There's an increment, there's a decrement, so you can actually change the state of this function once it's been called. And that's an example of a closure. So I've heard closure kind of like misused in a lot of different places, but this is essentially what a closure is. So there are some controversies with the newer versions of JavaScript. So if you're using ES6/2015, the class and the super keywords are considered controversial. And the new keyword is also considered controversial as well, even though that's not part of the ES6 spec. So one of the things that functional programmers try to do, especially functional programmers using JavaScript, try to persuade other JavaScript developers from doing is from using these keywords. Now there's some debate about that, and one of the things they're trying to do is they're trying to change I think some of the functionality, the way class works when you instantiate, when you try to instantiate objects. But one of the key things to remember is that class in JavaScript is different from like class in C# or Java. So that's the important thing to remember here. So this is an example of a C# class. So this is pretty boilerplate. You've got these properties up here at the top, and then you have this constructor here, which is can populate those properties. And then you have a method here called printAnimal, and depending on how many limbs the animal has, it does something different. So here's the same thing using the ES6 syntax. So one of the things you'll notice about this is actually pretty concise. It's actually it looks good and stuff like that, but one of the things that functional programmers will say, it's like, you really shouldn't do this way. You should probably try to use object literals. But this is essentially the same class in JavaScript as what we saw in C# before. So here's an example of invoking that. So here we're using the new keyword to essentially create a new animal. And then one of the things you'll notice here, if you look down here in this jQuery on the click event, if you try to call cat.printAnimal here, that's not going to work. And so one of the things you'll see a lot of, especially like in like React as an example, you'll see where people will bind the function to this. And that's because it's essentially it's out of scope. So in order to essentially get it inside or have it work with the same context, you'll have to bind. And you can also use a lambda expression here to do the same thing. So this is an example of essentially an object literal class. This is actually really kind of a factory method for creating that object literal. And so here, you know, we have two properties here for the name and the limbs for the animal, and then we're returning back an object literal here with a method here that essentially executes against this and does the same thing as the print animal that we saw before. And so one of the drawbacks with this approach is that there's a little bit of overhead from using the object literals. So there's a guy that does this as a YouTube channel called NonPure Functions, and it goes by MPJ. And one of the things he talks about on his computer, he says that it actually takes, I think, 2 microseconds to instantiate an object in JavaScript on his laptop. But then if he does it as an object literal, it takes 4 microseconds. So it takes twice as long to essentially instantiate that object. I think this is the better way of doing this, but there is some overhead with doing this. So what are some of the alternatives to using new and super? So one of the things Douglas Crockford proposed, I think probably about 10 years ago, was the object.create. And one of the things that's nice about object.create is that it avoids having to have constructors. So you can take an object prototype and then create a new object off of that, and then you can also pass in different properties or property objects inside of that to essentially construct a brand new object. And by default, the properties are not writable, enumerable, or configurable. So here's an example of a object literal for person. And then what we're doing is we're using object.create to create a new version of that person. And then we're setting a property on here called Dinesh. And then if you call say name, it'll say my name is Dinesh. But you can actually come in here now and you can overwrite that property since it was created outside of the object.create, and you can reassign the name to Guilfoyle, like as we're doing in this example, and then it'll say my name is Guilfoyle. But if you're creating a brand new object, you can actually pass in the my name as a property or as a property object. And if you look at the syntax here, you see that there's a get method that we're essentially passing into that properties object, which is basically going to say we're going to return Ehrlich. So now if we do boz.sayname, it'll say my name is Ehrlich. But then if you try to set that, since it's not writable, you'll get an error if you try to assign that. So it's my throw out to Silicon Valley. All right. So one of the things that a lot of the people that write about functional programming in JavaScript will say is like, well, inheritance is actually bad. A lot of times that people try to use inheritance in JavaScript like they would in Java or CSharp, and just because the way that inheritance is inherently different in JavaScript than it is in the CSharp and Java. So one of the things they suggest is using the object.assign to essentially take different objects with different properties and combine them together into a new object that has the properties that you need for that object. And that helps you avoid the gorilla banana problem that you get with classical inheritance chains. And this is also I use this in the little React programming I do. I use object.assign quite a bit for managing state. So that's something you'll see a lot of. So here in this example, we have two objects that take in essentially a constructing value of state. One says make sound, the other one says say name, and then below that, I'm actually creating a state, little state object, and then I can use the object.assign to essentially take the sounder and the namer objects and create a brand new cat object. And then here I'll make a sound ack and say my name is Bill. So I use this quite a bit. I find this to be really nice, and it avoids having to have these really long, awkward inheritance chains. So I agree with that. I think inheritance is overrated. So currying. Currying is basically allows you to have partial application of function calls. So you'll see a lot of syntax like this, where you say my function, and then in one set of parentheses you'll see red, and then the next you'll see blue. And so this is basically, we get this behavior because functions can return other functions. So if you look at this example, we have a greeter, and in this greeter function, we actually are returning another function that essentially will do this console.log here of the greeting and then their name. And so here in this first part of the example, we have this we call the greeter function, and then we set one to we call greet again, which calls the second function, and it says hi, there is David, and then hi, there is Andy for the second one. But you could also do it like this, where you have greeter, hi, and then call another set of parentheses. And so that's the example of currying. And one of the things I thought was interesting about currying just in general, it's like initially that was in the Swift specification, and I think they took it out of the Swift specification. So it was in, and then they took it out. They're doing that a lot with Swift. It's like they'll put language features in, they'll take it out, and then they'll put them back in. And so it's a democracy. So this is probably the example, I think, where people use functional or functional style JavaScript quite a bit, and that's with higher order functions. So essentially, functions allow you to pass in other functions as parameters. So you can pass your own behavior into functions. So we started seeing this probably about 6 or 7 years ago with .NET and CSharp, where you could have these lambda expressions that you could pass in. And that was really kind of my first taste of anything functional in a programming language. And so filter, map, and reduce are all considered higher order functions. This is an example. And so you can also pass in the hash rocket operator. Is used as a short form. And then this is also an example of where you're doing stuff declarative over imperative. So this is an example of what I call my imperative filter. So in this filter here, this is literally 10 lines of code. So what I'm doing here is I'm creating a filter function, and I want it to return back a new array from an array that gets passed in that has any value greater than 2. And you can see here I'm setting up a new array in here, and then I'm iterating over that array. I'm doing a comparison to make sure that it's greater than 2, and then I'm pushing that value into the new array if I'm doing that. And then I return that new array. Well, this is a lot more code than you need to filter down on an array. So here's the same thing essentially in one line of code. And the reason why we're able to do this is because there's a filter function that's built into the array prototype in JavaScript. And so here in this is the same array as I had before, but then I'm just calling filter, and then I'm passing in this inline function. That is basically any of the items that are passed in here that's greater than 2, that's what I want to get back out. So this is, I think, this is something that was actually introduced in ES5. So it hasn't really been in JavaScript that long, but it's a really neat feature. So map, here's an example where we're actually creating a map function as an anonymous function, and then we're calling map and just passing that in to the map on this array. And here, it's literally just multiplying the values by 2. And here's an example of the reduce function. So anybody that's done anything here with Hadoop, as an example, you probably heard these map reduce jobs. So that's where that comes from, map and reduce. So here, the reduce function takes a function that accepts parameters of an accumulator and an iterator. And in this example here, I'm just creating a sum. So I'm just having it go through each one and then add the value to the accumulator. And then I'm setting 0 as the start value. So that second parameter in here is the start value. So functors. So functors implement map. And they also hold a set of values. And so a map also returns a functor of the same size. And the array object is an example of a functor. This is an example. And filter, map, and reduce, which are higher order functions we've been talking about, it's like they all return functors. So that brings us to monads. And one of my other favorite Douglas Crawford quotes. I may be paraphrasing here, but he said, once somebody learns what a monad is, it becomes physically impossible for them to describe what a monad is to someone else. So I'm going to do my best to describe what a monad is.
Monad is just a monad in the category of the functors.
There you go. So monads are a type of functor, right? And they implement some form of flatmap. So it doesn't mean you have to have a function called flatmap. But it serves the same purpose. It's doing some type of flattening or transformation of your set of data. And the thing that's really nice about monads is it does a really good job of allowing developers to manage side effects. And if you're looking for examples of what a monad is, jQuery, the jQuery object is a monad. Promises are actually a form of monad as well. And if you've worked with streams in Node, Highland.js is a very popular library for working with streams. And that's also an example of monad. In fact, they have a method in there called flatmap. So if you I've been going through a lot of Swift code lately, and I've seen where people have, they're doing their own kind of like foundation classes, and you'll see map methods and flatmap methods quite a bit. And that's because they're trying to emulate these same monad patterns in Swift. Which brings us to promises. So promises are great because they give us kind of an easier implementation of handling asynchronous callbacks. And I think one of the things that people get frustrated with JavaScript, especially if they're doing any type of node development, is dealing with callbacks. So you start running into what people refer to as callback hell, where you have one callback that then calls another callback, then calls another callback. And promises are a little bit more elegant in handling this. So in the example I have on the third line there, it says I'm using the file system object to open up my file. And then if you look at that, we're passing a callback. And this is the standard kind of like error first, callback that we're used to seeing inside of JavaScript. And that can be implemented a lot easier if you're using a promise. So in the example here, the second from last line here, you see that we call the same method, but instead of passing a callback, we do a .then and do a .catch, and then inside the then and the catch, we pass in a higher order function or a handler essentially into those methods for handling the results, and that's how you can take advantage of synchronous behavior in JavaScript a little bit more elegantly. And also, these work well with the sync and wait keywords. So anybody that started using the sync and await keywords inside of JavaScript, essentially they're built to work with promises. So this is another good reason to use promises. So here's an example of a typical error first callback, and you see this quite a bit. I see this a lot in some of my older Node code, where in this example we're calling the stat method, and we're just telling it to look at the current directory, and then we're passing in a callback function that takes an error first, and then it passes the result. So you'll see code like this quite a bit in Node.js. So here's a nicer way of doing something like this. So here's the fetch method that's built into all the browsers now, and you could actually take this and run this in a browser right now as it is. And in this example, what it does is it's actually taking the response, and then the first then, we're basically telling it to return back response.json, which is another promise. And then inside of that next promise, it just uses the next .then to handle that. And so in the next .then, we're doing a console.log on the JSON. And then if for whatever reason, if you got an error or an error is thrown, then that would be handled by the .catch. So I like promises quite a bit, and it's something to keep in mind too. Is when you start writing your own APIs, is providing APIs like this, because and I think it makes handling the synchronous nature of JavaScript a lot easier, and plus it works well with async and await. So if you want to define a promise, this is pretty much all you have to do to define a promise. You just create a function, and then in the function you're going to return a new promise. And that promise, it takes a resolve and a reject handler. And then what you do is once you get to the part of your code that needs to handle the results or handle the error, you just pass that into the resolve or the reject. So one of the things that came out, I think in Node 8, it might have been earlier than Node 8, but I think it's a recent addition, is the util.promisefy function. And what's really nice about this is that if you have a error first callback and you want to turn it into a promise, all you have to do is use this util.promisefy on that method, and then it'll turn it into a promise. So this is really nice. So if you're complaining, it's like, oh, I got to use this API and it uses all these error first callbacks, you can use this to convert it into a promise. So here's an example here where we're doing essentially the same thing but using async and await. So if you absolutely hate doing any kind of callback whatsoever, you just want to do something as if you were writing a synchronous function, the sync and await keywords. This is added a while ago to C# and .NET, and it's been added to JavaScript. And so if you're running the latest versions of Node, the sync and await keywords are in there. And essentially what's happening here is you just put the await in front of your promise instead of having to do all the then and catch calls after you do this method call. You just basically put await in front of it and you just put the return value that you want to have inside there. Of course, you're still going to have to handle any errors that are thrown, but that's essentially how you can use the sync and await with promises. Has anybody seen this error before?
Yeah. Only .NET programmers.
Yeah, so I spent 11 years of my career doing .NET just about full time, and I'm not filming my head right now, but anybody that can see me can see that I'm bald. And I'm pretty convinced that one of the reasons why I'm bald is because it seems like I spent 9/10 of my debugging with Node either trying to track down object reference errors or view state errors. If you're doing anything with web forms, don't use web forms. Don't let your kids use web forms. So Andrew Selberg, the guy who is the inventor of C# and also he runs the project for TypeScript, he said that 50% of the bugs that you see in .NET are basically this kind of bug, the object null reference exception. It's also, you see this a lot in Java as well. And one of the things I think they kind of argued about when they were starting to do the language in .NET was whether or not they even have a null. And so null is actually kind of controversial in a way. And if they did not have the null, they probably would have gotten rid of about 50% of the errors in .NET. And I heard somebody refer to it as like the $3 million mistake or the $50 million mistake or something like that. It's got to be at least $1 billion, yeah.
That's the guy who created null.
Yeah, it's got to be at least, yes. So that brings us to mutable.
Put it in there because it was so easy to implement.
Well, yeah. So it's essentially it's funny how many different languages have some concept of null. So I do the bulk of my day job is actually working with Objective-C code and now we're starting to do some stuff with Swift, and I also do a lot of stuff with Java as well. But it's like in Swift, like they try to, you have all these pre-existing frameworks that have to deal with null. So you have to have a way of dealing with it. Unfortunately, when you're doing a language like Swift, and so they came up with this idea of optionals, which is really nice. Optional, you can create a value type or specifically a reference type, like a string as an example. And a string can be null, like in C# and Java, a string can be null. But you can set it up so that just by default it's mutable. So you have to set the value so you don't run into those errors. And then you start running into all these things where you have all these values. In Objective-C, they call them nil. They don't call them null. But essentially it's the same thing. And so you start running into all this optional chaining and checking and stuff like that. So it's like they try to get rid of it, but it's still there. You still have to deal with it. So yeah, that brings me to Immutable.js. So Immutable.js is just a JavaScript framework, but it has a set of types. Map, list, and range are examples of those. And when you create something as a map or list or range in Immutable.js, it's immutable. Once you set it, you can't change it. You can do transformations over those and create or basically pull out different values based off of those transformations. But the key thing there is that one of the things they did with that is they wanted to be able to avoid null. And I have this line here. It's like state is the source of many errors and the root of all evil. Well, state really is the root of all evil. And one of the things they try to encourage, if you're starting to use ES6 in 2015, try to use the const and let keywords whenever possible. So it's one of the things. It's funny. I've been going through a lot of my older Node code, and I was just like, I'm almost embarrassed by how many vars are in there. But these are relatively recent changes that have been made to JavaScript. So I think hopefully all the browsers now support them. If you're writing for Node, Node supports them now as well. So as long as you're running on a fairly modern version of Node and you have up-to-date browsers, you can use those keywords. There's also another library that's popular for doing this called Mori, and it's written in ClojureScript. That was one of the functional languages that I didn't mention at the beginning. Clojure is considered a functional programming language as well. And it pretty much does the same thing as Immutable.js. Some of the method calls are a little bit different, but I wanted to go ahead and mention those as well.
If you're going to look into ClojureScript, you should mention that is C-L-O-J-U-R-E.
Oh, I'm sorry, I misspelled that. Well, I'll fix that.
Not to be confused with the Google Clojure libraries.
Yes, this is different. So,
but it is a list.
All right. So something else I also wanted to do is talk about the proposals for the bind and pipe operators. And so the bind operator uses what's called, I think this is referred to as the Elvis operator. I'm not sure why it's called the Elvis operator. Maybe somebody could explain that to me.
It looks like Elvis's hat. It's like a banana.
Okay. And
Just two colons?
yes.
That is not the Elvis operator.
No,
It's not?
No.
it's one of
Elvis operator would be question mark.
Oh, okay. All right. Well, you'll have to take that up with Michael Sneed because he referred to it as the Elvis operator in his blog post. So yeah, and then we're also going to talk about the pipe operator. So Michael Sneed, who did the presentation last month on type system in JavaScript, he couldn't make it tonight because he's in Singapore. But he had a really nice post on Medium talking about the bind operator, and so he's this is one of the examples from his blog post where you can see where they're using the double colons here. And I remember I replied to him at the time after he did the post. I was like, I'm personally not a big fan of this one just because to me the double colon, it's already used in a lot of different languages for completely different things. So like in C++, it's used essentially as like a class or a static accessor to the methods in C++. And so I don't like it because of that, but I guess if they introduced it, I could get used to it. So this is an example of the pipe operator, or how you could use the pipe operator. So in this example right here, we have three different functions that take a string parameter and pass out a string parameter. And if you look right here, in this example right here, they're calling double save first, and then they're wrapping that around a capitalize, which capitalizes the first character, and then it puts an exclamation point at the end. So if you look at the order of this, it's like, logically in your mind, like when you're looking at things, you look at things, at least in English, we look at things from left to right. But this is an example of where everything's kind of occurring from right to left. And then if you look at the console.log here, it return hello hello with an exclamation point. But with this proposal for the pipe operator, you could actually do it like this, where you could say, here's my string, and you see this a lot in languages like Erlang as an example. I think this pipe operator is used in Erlang. And here you just say, well, we're going to call double say, then we're going to call capitalize, and then we're going to call exclaim. So you're actually able to put the functions in the order that they actually operate in. And that would return the same results here. Or you could do it like that, where you just piped into the console.log and got the same results out that way as well. So, are there any questions? No questions? Yes?
So if you're a functional programmer, how do you use promises?
How do you use promises? So promises, I think, are really good. Like any place where you're going to have to wait for a response or handle something asynchronously. So think about like a database call, or you think about like something where you're working with the file system. So that's inherently where you start running into issues with resources being locked up. And I think one of the things that they did that was really interesting in Windows 10, or not even Windows 10, I think it was Windows 8, when there were any kernel level operation that happened in the Windows kernel, anything that took longer than 40 milliseconds, they had to create an asynchronous method for handling that. And one of the things I noticed, I have like an older PC at home, and this is an example. I would, when I originally got it, I got it like around 2009, I'd say, and I installed Windows Vista on it, and it ran okay. It ran okay on this machine, and then when Windows 7 came out, I installed Windows 7, and it actually got faster after I installed Windows 7. And that's because they started making these optimizations in the Windows kernel. And then when Windows 8 came out, it got even faster. And then when 8.1 came out, it got even faster. And then finally, I installed Windows 10 on it, and Windows 10 was about the same as Windows 8.1 as far as the speed I was getting on this PC. But then the latest update to Windows 10 came out, and it won't run on my machine anymore because it's 10 years old, or close to 10 years old. So I can't say how the current version of Windows is doing. I have it installed on another laptop at work, but this is the funny thing about Windows. I'm actually doing this presentation on a Mac tonight, and one of the things that I thought was funny, it's like when I started my new job, we actually do some .NET programming at my job. It's like, well, I need to have Windows, and this is really before .NET Core was. I think .NET Core is still technically kind of half baked. It's like it seems like it's kind of a moving work in progress. I don't want to say anything insulting to the .NET Core people, but we're not using it yet in my company. So it's like I need to have Windows installed on my laptop at work, and so I set up a VM and I installed Windows 10 on my VM. And I was like, oh, cool, I'll be able to use Visual Studio on this. And I literally have had Windows turned on, I think, a total of 3 times since I started my job a year ago. So it's not insult. I actually like Windows, but I haven't had to use it that much. Any other questions?
So you mentioned WebAssembly.
Yes.
What's the status?
So WebAssembly essentially right now, I refer to it as I wouldn't call it proof of concept. I call it what do they call it in startups? The minimal viable product, right? So essentially what we have right now is the minimal viable product. There's some really great demos and stuff where people have taken things that have been written in Unreal and they've compiled them down into awesome.js or into WebAssembly. And I think Unity, the people that are familiar with Unity at all, Unity is a game engine / development environment. I believe that they have they can actually compile down into WebAssembly. One of the demos I've seen was created with Unity, which is ironic because you use to program that, to do your own programming inside of Unity, you use something called Unity Script, which is basically just JavaScript or C#. So, but yeah, it's like right now you can kind of write out to the canvas in the browser and stuff like that, but there's a lot of stuff they need to add in, like things that are accessible to JavaScript inside the browser. Not all those things are accessible to WebAssembly. So it's, like I said, it's a version 1.0 right now, what they have. But I think it's going to be a game changer because like you take people like Bill, for example. Bill, you hate JavaScript, right? Hey. So what you could do is you could actually, you could say, yeah, you could.
You are. I'm trying to make sure he gets all the functional programming stuff right.
Yes. So that's the thing. And so with WebAssembly, you could take Rust or you could take Scala as an example. Like I know there's Scala.js where you can essentially it's doing the same thing that Osm was doing, where they're taking they're doing transpilation, but now you can actually do compilation. And I watched a presentation online that was given at one of the New York-based conferences, and they actually showed what the kind of like its own version of the machine language, and it looks very close to Scheme, or in particular like Lisp. The machine language looks very similar to, or their assembly looks very similar to Lisp. So, but yeah, then when you look at the actual machine code, it looks like machine code that you would see coming from from the CLR or something like that. So. But yeah, I think that's gonna be a game changer. So anybody who wants to present on that, contact me after the presentation. Any more questions? Yes, Ben.
Can you tell us a little more about monads?
Monads. So monads, you can do a whole presentation just on monads. And as a matter of fact, I suggest one. Douglas Crockford did one on monads that actually got him, I think, uninvited from November. So I won't say what the title of it was, but there's a pretty good. I'll post it onto our Meetup site. There's a really good blog post going over all the different types of monads that you can have. So there's a lot of patterns that are used with monads. Like there's the nothing monad, and there's also like an identity monad. There's lots of different types of monads. And like I was saying before, if you're looking for an example of a monad, Highland.js is a perfect example of something. It's a library, but it also creates an object that's a monad. And jQuery, if you've ever worked with jQuery essentially is a monad. When you use the selector syntax, and it basically returns back out this jQuery object, that jQuery object is a monad. So,
The first one or the one returned?
the one returned.
What makes it?
What makes it a monad? This goes back to what Douglas Crockford was saying. It's like once you learn what a monad is, it becomes impossible to describe it to somebody else what a monad is. But the key thing is like I was saying before, it's like monads are essentially. Actually, you came up with a definition. What was your definition, Bill, of a monad?
It's just a monoid in the category of endofunctors.
There you go.
A monad is just a monoid in the category of endofunctors. The term monad is scary, simply because people say things like that. In essence, what it boils down to is sequencing. For instance, map. A functor, what we're talking about, is something that implements the map. That allows you to change a thing. This is the other thing that makes it different. It's all very abstract. It allows you to change a thing with a function that takes it. If I've got a functor of type A, it allows me to call map, which is a function from A to B, and gives me a functor type B. So it's just a very simple business. Whereas a monad takes essentially the same thing, but the function that you pass in is not A to B, it's an A to the monad of B. So it allows you to take the output of, or the content of the monad and change that into another monad, and then you can chain that with sending down another monad. So the promise is a great example of that, where you can have .net.
Mm-hmm.
There are additional laws involved with making sure that it's an actual monad instead of just something that has It's a series of transformations on
Yeah.
a thing.
So you see that a lot in jQuery, where somebody will pull back, let's say all the A elements on a page, and then with that list of A elements, maybe they want to add like a new event handler, so they run another thing on that, and then they can do another dot method call on that, and you can just chain all these different calls. And the thing that's great about it is that it helps you avoid, issues with global, global state, and then it's really good at managing that. And so when people are working with streams, as an example, it's very popular for working with streams where let's say you're pulling in let's say you have a document that's 100 megabytes in size, right? And I used to run into this problem all the time back when I was doing, God forbid, Cold Fusion. We had a limitation. We had a limitation on our server, like if we were processing XML, we could any process we did had to run within 30 seconds. If it took longer than 30 seconds, we would kill the process so you never finish. And so one of the reasons why we started using Java and .NET at that company was because we were able to get around the 30-second timeout issue. But the key thing is that Cold Fusion has an XML parser in it, but it wasn't a stack-based parser. It was what's the name of the parser in Java where you have to?
Stacks.
I'm sorry?
Stacks.
Well, Stacks is a library for working with, and that's a great library for working with XML and Java. But like in Cold Fusion, essentially you have to create a data structure all at once. So if you had something that was, let's say, 500 megabytes in size, there's no way you're going to be able to process that in 30 seconds on a server running JRun, which is what we were using. So with pull-based parsers and event-based parsers, as an example, event-based parser, it's very similar to the way like a lot of stream frameworks work. So the stream framework, you can take a text file, and let's say you need to process that text file. You can essentially process it as a stream, and then you can have these transformations that occur on that stream. You can do all this dot call syntax to get the transformation just the way you want, and then at the end, you can write it out to a new stream. And the thing that's great about that is it's very efficient with memory when you do it that way, because you don't have to open everything up at once. It's a very nice way of working with larger data sets. So, yes, Jody.
Was the talk by Douglas Crawford that got him banned labeled monads and gonads?
I'm not going to say it because I'm not. What did you say?
Monads and gonads?
Yeah, that was it. So I'm not going to repeat it because I don't want to get banned from November. So anyways, but Douglas Crawford's a great guy. He's a little bit cranky, but there's some great presentations that are on YouTube now from talks he gave at Yahoo when he still worked at Yahoo, and he's also the author of JavaScript: The Good Parts. And he was one of those people where I think when he first got into web programming and looked at JavaScript, he was like, "What the heck is this?" And then after he looked at it for a while, he was like, "Actually, there's actually some good aspects to it." And then after he understood what Brendan Eich was trying to do with the language, it's like it kind of clicked with him. There's still these bad parts. There's bad parts in it, but just over the years, I think JavaScript developers have done a better job of dealing with the handling the bad parts and writing better good parts. So some of the resources I want to kind of point people to, I put all the code examples I have tonight up on GitHub. I'm going to actually put these up onto our Meetup site so that you can take a look at these there. There's also this woman's done a number of different presentations that are all on YouTube. I have two of the links up here. Her name's Anjana Vakil, and actually she was interviewed on Hansel Minutes last week. And she's done 2 talks on functional programming and with functional data structures that are really good. A lot of the stuff I was talking about, like the controversy over the class keyword and all that, Eric Elliott is another good resource. He posts regularly to Medium and to Twitter. There's a couple talks he also has online as well. and he wrote the O'Reilly JavaScript applications book. And so he's a good resource for this too. And he heavily promotes this style of programming as well. And then something I get a really good kick out of it. Has anybody here seen Fun Function on YouTube? Fun Function is great. MPJ is a Swedish developer for Spotify that does these weekly episodes where he goes over all these different functional programming concepts that you can use inside of JavaScript. And he does other things too. Like last week he did one on basically Circle CI and being able to do basically continuous integration and stuff like that with your JavaScript applications. He's a great resource and also very, very entertaining as well. So he's a good resource as well. And then, as I was saying before, Douglas Crockford. There's some great, typically like an hour long, and the presentation you're talking about, which I won't rename, that one is it's like about an hour long presentation, but he goes into all the different things you can do with monads in JavaScript. So that's an excellent presentation to watch as well. So I just want to thank everybody for coming out. Yes, Bill.
Another local resource, if you're interested, is we do have a JaxNode Elixir meetup that.
That's true.
Just general functional programming.
And it meets here.
The next talk
Like
is
every other
August.
meetup.
Next talk is August 10th.
The next talk is August 10th. I'm not sure what that
It's gonna be huge.
is.
Everyone should come
Phoenix
out.
channels.
Phoenix channels, okay. The one after that is going to be me doing